Hello and welcome to episode 123 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Andy, you suggested that today we would talk about functional programming. So, what is functional programming? And please answer this as if you're talking to an idiot.
Well, you said, isn't that going to be really boring? And I said, maybe. So we'll see how we go. Functional programming is a style of programming. I think we've actually mentioned it on a previous podcast. What's weird about it is it's actually a style of programming where you're not allowed to do all the things you would normally do in programming. So the question would be, why would you want to do that? Why would you want to give yourself fewer tools to work with? And sometimes the answers can get quite obscure, like it makes it more analyzable by a mathematician, like makes your code more analyzable or something like that. But in practice, it's because the code often comes out feeling better. That's what I think about it. I don't know what everyone else's experience of it is and whether you feel similarly.
Yeah, if we're talking just about the functional programming paradigm, not necessarily the implementations of it in various languages, I think your code can come out more concise in a vacuum, if that makes sense. So looking at little pieces of code, it's much easier to analyze them in little snippets. I am personally not a huge fan of pure functional programming, as in all the way down. I prefer a little bit more of a mix because I think humans tend to think more in a procedural manner. And so breaking it into this functional paradigm is beneficial. You can see that there are things that are more testable. Code can end up, I don't want to say just easier to read, but it can end up in ways that it's easier to test. But it is also harder to grok sometimes. And I think that's why functional programming in and of itself has almost a mystical air to it.
So I am going to get back to what it is in a second, but I just wanted to see whether Amalith had any thoughts about how it feels.
I've only done a tiny bit of functional programming, some intro courses on Haskell. I think the paradigm is very interesting and alluring, but that's probably mostly because I haven't done much of it yet. It's interesting and shiny. One of the most interesting features of maybe Haskell in particular, I don't remember if it's common among functional languages, but lazy evaluation is really cool.
Right. That's a whole other thing that I wasn't going to talk about. No, we have to talk about that too. All right, so back to what it is. So I guess the easiest way to come at it and understand what it is one of the key rules in functional programming is when you write a function and someone calls it, if they call that function again with the same arguments they called it with last time, they will always get the same answer. Immediately thinking about that, you might think, well, isn't that always true with any function? But it's not. There's loads of reasons why you might get a different answer from a function if you call it again, like it might be a different time of day. So if your function is tell me what time it is, it might give you a different answer next time. So in functional programming, you can't do that. You have to do it a different way. You can obviously do things like that, but you have to approach them a different way. And there's other things as well. So if your function actually responds to something else that changed somewhere else in your program, and that affects what answer it gives you, then it might give you a different answer the next time you call it from the last time you called it. And so in functional programming, that wouldn't be allowed. It has to be that every time your function is called with a certain set of arguments, you get back exactly the same answer every time.
Yeah, and so people might have heard that called purity or function purity. So a pure function is one that only evaluates its arguments and then sends back its return, right? So what Andy was saying there is it can't reference anything other than the arguments in order to do its job. So some of the other things that are very, very common in programming, things that you might reference outside of an argument to a function would be the environment. Think of environment variables, or think of, time like Andy referenced, or it could be any number of things, disk IO, or doing any sort of thing that touches the outside world outside of the function would make a function impure.
Even printing to standard out.
Exactly. Touching any kind of I/O, whether it be standard out or disk I/O, all of that is something that has to affect the outside world. And you'll hear those terms as well, the effects of a function. So probably all, but I would definitely say most functional languages do give you the a break glass scenario where you can have an impure function, although it's not as common, right? You try to do things in a purely functional way. But there are ways to get around that because sometimes you just have to talk to the outside world outside of your function. But there are benefits to staying pure. So some of those are testability, readability. Like there are very, very good reasons to have a purely functional function or a purely pure functional function.
Yeah, I mean, programs are useless if they don't either print something out or read files or write files or something, right? So at some point, this either has to break down or you have to find ways around that. So for me, where I see real benefits from functional programming is if like most of my code is pure in this way, and then there's bits where it's not. And the reason why I like it is because it means if I'm trying to understand a function, I only have to read that function to know what's going to happen. And that is huge for just how easy it is to think about stuff and coincidentally how easy it is to test stuff if you do it right.
This is one of those areas too where learning the functional paradigm or testing out a functional language can give you new ways to look at code. So like Andy's saying, when you're writing code in a non-functional language or in one that is only partially functional, having some of that background of like, oh, if I can keep my functions pure, then I might be able to better understand the code by just looking at its signature, or better understand the code by just looking at the code inside of this one function. So there are benefits from looking at other paradigms, even if the language you're using right now is not a purely functional language.
There's another real advantage to a pure function, which is that it can run in parallel with anything else that's going on, and you know it will never interfere with that other thing. So that can give you a lot of power to just massively parallelize your stuff if you know that each of the functions that's running is completely independent from everything else.
I think that might also touch on some of the implementations of functional languages. So for example, a lot of functional languages will do things like make everything immutable. The only way to mutate something is to make a copy of it and do something with that copy. Where what Andy is saying about everything being in parallel, that would be true if you don't support like mutable pointers as an argument or something along those lines. So there are aspects where like some languages will actually try to hide those like, yes, maybe a mutable pointer as an argument would not allow you to do something in parallel. However, pragmatically in the language, we don't allow you to use mutable pointers as an argument. So something to keep that parallelizability.
If you keep a lot of things immutable, then you almost get like pure stuff for free. And so I think that's a good reason why modern languages are quite clear about what can change and what can't change, right? So that it's easier for you, if you're trying to keep things immutable, to know that you are and not accidentally start changing things later. So Rust, for example, by default, the variables are, they're still called variables, but they're immutable and so they don't vary.
Rust is an interesting one here because it is somewhat functional, but also somewhat procedural. And you can kind of pick and choose which paradigm you'd like to use. And even the standard library has some parts that are very functional and other parts that are not. So that's also probably why that language in particular jives with the way that I like to think about things, is because it kind of gives you the tools to do some things in a functional manner, but you're not forced to. It prefers immutability, but you don't have to.
All right. So I think we need to deal with the elephant in the room, which is it's just elitist and just for like people who have their head in the clouds and don't write actual programs. Why do people think it's like that? And is it like that?
My speculation, and I don't know this for a fact, is that functional programming, because it is very tied in with like math communities, or it's very close to the way you would write out a math formula, that it has a very academic air to it. There's also some of the languages that came out of academia or are still in academia that have a very functional style to them. So there's a big overlap between academia and functional programming. That doesn't mean it has to be that way. I think just pragmatically in the real world, that's kind of how it is.
So is functional programming used for really complicated maths then? The kind of maths where you can't really do it yourself with a pen and paper and a calculator. You need to write a computer program to like prove your theorem or whatever. Is that one of the first areas that functional programming was used for?
I don't know if it's used much for pure maths. It might well be. I'm not aware of it. What I know it's used for is like financial stuff. There was a big trend for it, say maybe 10 years ago or so, where all the kind of finance houses doing their evil money stuff were just hiring Haskell people for all of that. Now they're hiring Rust people.
And I don't know this to be a fact. I have not used languages like Idris or Coq, but those types of like almost theorem proving languages, I know all of the friends that I have that are very into functional programming are also very into those style of languages that are like theorem proving. So I'm sure there is a decent level of overlap there as well.
There is a link because when the Haskell compiler checks your code, checks that it's valid Haskell, it's apparently, I don't understand how, actually doing theorem proving. It's doing the same thing as if you were trying to prove mathematical theorem.
Another thing functional programming languages are often used for is parsing. I think GitHub's syntax highlighter, that like when you go to a web page and look at some code that has highlighting, that highlighting was generated with a Haskell program. And at MBOA, we have a project called Chiagram that serves as a bridge between a few different protocols. I think email and XMPP are two of the things it does. But it translates between those two systems because it's so good at parsing.
The functional style is really good for parsing and stuff like that. And Haskell has some good support built in. I think one of the reasons why functional programming is sometimes seen as just like elitist or not relevant to the real world is basically that Haskell is so different from all the other languages and has a lot of ideas in it that are not just functional programming ideas. Like some of them are kind of enabled because the functional programming thing lets you do kind of weird high-level programs that kind of modify your programs type stuff. I find it a bit annoying that Haskell is like the thing we always talk about when we talk about functional programming, because it's so many other things as well as functional. You know, it's so different from all our other languages. It's totally cool, but it is different in lots of ways.
There's also just a lot of different terminology, and a lot of it is like programming theory terminology. And so it's really, really difficult to talk to somebody about functional programming without them throwing out a bunch of terms that are either rooted in academia or are difficult to talk about without already knowing a lot of the other underlying principles that led to those terms. So for example, like asking somebody to explain monads to you is very, very, very difficult. In fact, I don't actually know that I've even seen a good, well, I mean, there's several good tutorials on what is a monad, but it's very difficult for someone to explain what a monad is without just using a bunch of other terms that are equally as confusing.
Yeah, and I don't think you need to know what a monad is either to write functional code in your language of choice or even to write Haskell. Like at some point when you're writing Haskell, you might eventually figure out why they're useful, but you really don't need to know what it is. And when people come along and tell you the technical definition of it rather than how to use it, I really find that misleading.
And there's definitely nothing funny about the word monads.
By the way, just as a tip, if someone's interested in learning Haskell type stuff and found Haskell difficult or just finds the whole Haskell idea intimidating, I would suggest trying out the Elm language, which has the same type of syntax as Haskell, not exactly the same, but very similar. But it doesn't use all the advanced concepts in Haskell, so it's a good one to try out. And you can make websites with it, so it's nice and easy to get into.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at linuxdevtime.com/support. When you said that you wanted to talk about this, I thought, right, I'd better do at least some research. So I went to YouTube and typed in functional programming for dummies. And I came across a computer file video from quite a while ago. And so now I'm a complete expert, obviously, because I watched this like 10-minute video. But in that video, they talked about how, because it's quite easy to run things in parallel, it's quite suited to modern CPUs that have got loads of cores and threads. So is that still the case?
I think there's a lot of things that it depends on. So because of that implementation detail and the difference between the implementation and the language itself and what the language lets you express, there are times where the language that you are using has concepts like purely immutable or whatever it may be. And the language may allow you to express things in a very parallel manner. but then it also needs to be taken advantage of on the underlying like implementation of that language. So what I'm struggling to say is that the implementation of the language matters just as much as the language itself. And if the implementation takes advantage of that, then yes, functional programs, I think, in general, have a better chance at being able to run subsets of those programs in parallel.
Yeah, although I sometimes think that is more in theory than in practice so far.
I think the reason behind that, though, is because the implementation is often not able to take advantage of the language's constructs. And we see this actually happen quite often in Rust, not necessarily from a functional aspect, but Rust, the language, may say something like, these two mutable pointers can't ever alias. However, when we get all the way down into like the lower levels of the language or the assembly language, like down far below Rust itself, the implementation is dealing with two mutable pointers. So the implementation itself is not able to take advantage of the fact that Rust, the language, has said, yes, this is not possible. This is safe to do. The implementation down below that has to be more conservative than the language. And I think the same thing happens with some functional languages as well, or functional implementations.
All right, so I feel like we should make suggestions if someone's listening and wants to try out coding in a functional style or in a functional language. Where should you start?
I've always heard great things about things like Clojure or Scala or F#. Like these are all languages that I hear nothing but praise about, and they are far more into the functional category, but they don't get all of the same angst or kind of elitism as something like Haskell. So those might be more approachable ways to jump into functional programming.
I've spent a little bit of time going through the Beautiful Racket course created by Matthew Butterick, and it's been really interesting. Racket is another of the functional programming languages, but it's actually often used to create other languages. So you can, for example, come up with your own domain-specific language for a particular thing that lets you write a short text file in your language and then run it through your Racket program to do a web server or something. It allows you to do really cool things because the standard library is so large, and you can take advantage of that standard library in your domain-specific language.
And of course, I think a good opportunity to fanboy over Rust some more would be that's another one where you can kind of dip your toes in. You can use some functional aspects, but you're not forced into it all the time. So there are plenty of tutorials out there that talk about the functional aspects of Rust or functional programming in Rust and trying to do that more deliberately.
Yeah, Racket is from the Lisp family of languages. I'm a huge fan of Lisp for playing, maybe not for production use. I really like Scheme Lisp, which is very closely related to Racket. I think of Lisp as being basically like Python, but with a weird different syntax that is beautiful when you get your head around it. I found when I was playing with Lisp, that helped me get my head around how you could write code without having variables that actually change at all. And once I had my head around it, it really improved my code in other languages.
Also, using any language that allows you to pass around functions as a first-class citizen, that's another way to kind of dip your toes into a functional paradigm of programming.
Yeah, exactly. So in JavaScript, there's loads and loads of passing functions as arguments into other functions, returning functions from other functions. And that used to be something that was like special and weird about Lisp, and now everyone can do it. But yeah, JavaScript was one of the early ones. So there's loads of stuff in JavaScript that's implemented using that kind of functionality.
And you'll see it a lot of times too in languages that have like really good iterator support. A lot of the different like map and reduce and fold and all of those I think come out of some like functional paradigms.
I think we should like try and make the connection to what's that got to do with pure functions? And it's really because if you've got these little functions that just do one small thing and they're really self-contained, then you can pass them as arguments to a function like, or a thing like map to say, please run this function on everything in this list or whatever. And because it's just like a self-contained thing, the function, you can pass it in and use it in that way.
I suppose my ultimate question for all of you is this. What percentage of your day-to-day programming that you do for work and for fun is functional, and why is that percentage not higher?
I would say these days, 95% of the code I write is influenced by thinking in this way. And something like 40% of the functions I write are actually pure in the sense that you're guaranteed what answer you get if you pass in the same arguments.
Yeah, I would say a lot of the code that I write is influenced by functional programming. And because I do a decent amount of programming in Rust, there is some functional aspect to it. But I would say like of the code that I write, probably less than 50% is actually functional. But I am constantly thinking about how can I make these functions more pure, or even doing some things like there's some projects in Zig that do as much as like passing time and everything down into the functions to make almost every function pure. Things like memory allocation, like as much as you can pass into the function so that it never has to touch the outside world. So that's always in the back of my mind as I'm writing, is trying to get more towards that approach. But I don't think I'd ever reach 100%.
I'm very much the same way. I don't think any of the code I write day to day is explicitly functional, but I do very much try to write functions that lean towards being more pure because it just feels simpler and cleaner.
Yeah, and quite often when I'm stuck in a horrible function where all kinds of things are going on all at the same time, I'll be thinking, how can I get myself out of this mess? And one way out of the mess is to think, well, actually, this bit of work that this function does actually could be a separate little function that just works in this clean, simple way. So I'll extract that out, and then maybe some of the rest of it has to stay more complex. Once I've extracted it out, I can write a test for it, and then I know it really works the way I thought it worked.
Does your approach to testing functional programs differ significantly from your approach to testing imperative or procedural programs?
Yeah, I think it basically it just makes me happy. Right? if I've got functional code, what that means is I just have to make the things that I'm going to pass in, call the function, check the answer, and I know that my test is testing that thing. If it's not functional, that means there's something else in the background that I might or might not know about and might or might not change under me that I have to control. So, for example, like worst case scenario, I have to like change the system clock to be a particular time of day before I run my test, otherwise it might fail. Or, a better example might be there's some global variable somewhere and I know it can't be null at the time when this function runs, otherwise this function crashes, or, whatever it is, something like that. And so as soon as I've got non-functional code, I'm thinking, what kind of weird, subtle thing have I forgotten that is going on somewhere underneath that I have to control for my test to make sense?
Not only like, is this database mocked in my test, but is it mocked the same way as the real database?
Well, I think you're touching on something there, like in a purely functional test, there is no database unless you pass it in to the function. The reason I bring that up is because in, I think, the real world or in practice in our day-to-day jobs, you'll end up needing to interact with the outside world in so many different ways. And at least giving some conscious thought to how could I break up the parts of the program so that some of them can be purely functional and others of them might have these external effects. And how can I split those out? How can I pass them into one another? How can I contain the parts that have the effects and the parts that are pure? And just thinking about that and putting some thought into it up front, I think generally gives a better test suite.
Yeah, so you're touching on something that some people call dependency injection, right? So there's multiple ways that you could write code that, say, talks to a database or talks to a web service or something like that. One way is that it could just bring up the libraries that you use to talk to the database and use them. And another way is that you could pass something into that code which can substitute for your database or could be actually your database. And that's sometimes called injecting your dependencies, right? Which just means passing in arguments, an argument called DB, which represents something which at test time is not actually a database, but acts like a database. And then at production time, that actually is your database that you're passing in, or something that lets you talk to your database. By the way, if we're going to talk about dependency injection, I have to say, I'm not talking about dependency injection frameworks, which I hate. I'm just talking about dependency injection, the idea, which basically just means passing things in as arguments.
And it comes with some pitfalls as well, just like mocking does, where you're only testing the return of the mock or whatever the injected dependency returns, and you're not necessarily testing what will happen in the real world. So you have to be more vigilant to add in those additional test cases, edge cases, and make sure your mocks or the things that you're injecting actually represent the real world or real world scenarios.
Yeah, so it's slightly tangential to technically pure functional programming. But yeah, if I'm passing in a complicated mock into a function, even if it's pure, I feel worried that I've done it wrong, because the whole point is your test is supposed to be kind of dumb and obvious. And if your mock is no longer dumb and obvious, then you've probably messed it up somehow.
I will say, though, just passing in time as an argument is actually a really cool call it a hack that you can do with testing, because if your functions take in time as an argument and just don't try to touch the system time, then it turns out you can do things like forward dating the time, backward dating the time. You can do all kinds of really cool things in your test scenario that are really, really difficult to do in the real world because you can't actually do anything. So putting some thought into what you're passing in and what external effects you're actually touching, and just doing little things like passing in the time can be an amazing little hack for your testing frameworks or your programs in general.
Right, well, we'd better get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
I've been Andy, and I'm sorry for suggesting this episode.
See you later.